Imagine looking up at the night sky and suddenly realizing that the fundamental shape of literally everything you're seeing has been vastly misunderstood. Welcome to today's Explainer. I was recently diving into some genuinely fascinating new research, and today we're exploring a radical cosmological framework that challenges the very foundation of modern physics. It completely redefines how we picture the cosmos, shifting us away from a universe filled with undetectable dark matter and moving us towards something way more elegant. Astrophysics is in crisis because the universe is expanding at two entirely different speeds. But what if we just live inside a giant donut? I know, it sounds like pure science fiction, or, maybe just a late night snack craving. But as we'll see through the latest research we're unpacking today, the geometry of a donut, which is mathematically known as a torus, might actually be the literal key to unlocking the cosmos. Okay, let's dive into this. Part 1. A universe in crisis. The Hubble Tension. So for decades now, we've measured how fast the universe is expanding. But there is a glaring, massive problem. Our two absolute best methods violently disagree with each other. When we look at the early universe using the cosmic microwave background, we get a highly precise expansion rate of 67.4 kilometers per second per megaparsec. But when we measure the local, modern universe using the distance ladder of supernovae, we get 73.0. These two highly precise numbers just do not match. It's like measuring your living room from the left side and getting 20 feet and then measuring from the right side and getting 22. It implies that something is fundamentally broken in our standard model of physics. And because both of these measurements have been verified over and over again, cosmologists are currently in a genuine state of crisis. To hold the standard model together in the face of these crazy anomalies, astrophysics relies heavily on invisible placeholders, dark matter and dark energy. Right now, conventional models dictate that these two mysterious substances make up 95% of the cosmos. Just wrap your head around that for a second. 95%. That means 95% of our universe is completely unseen, unproven, and essentially theoretically patched together just to make the math work out. We're literally building our entire understanding of reality on the assumption that almost everything in it is completely invisible to us. And the cracks are only growing wider. The James Webb Space Telescope is finding mature galaxies way, way too early in cosmic time. Observations like the Bullet Cluster show matter and gravity completely decoupled. And to fix these glaring holes, the standard lambda CDM model now requires 6 or more free parameters. In physics, a free parameter is basically an adjustable dial you spin to force the math to match reality. If your equation doesn't fit the telescope data, well, you just invent a new invisible particle or force and twist the dial until it does. As the source material brilliantly puts it, physics has been treating the symptoms by inventing invisible water rather than realizing the river simply runs deeper. Which brings us to Part 2, the donut universe, introducing the ITSM paradigm shift. Instead of inventing more invisible particles, the ITSM proposes a brilliant geometric solution, the 3-torus manifold. Picture a sleek, massive 3D donut completely replacing the concept of a dark matter halo. In this framework, we actually have to rethink the very vacuum of space. It's not just empty nothingness, it's an active, superfluid medium governed by the topological structure of a torus. This incredibly elegant geometry completely changes how gravity and cosmic expansion behave, and the best part, it does it without needing a single drop of dark matter. It implies the universe has a specific, highly active shape that guides the motion of galaxies exactly like currents in a river. Now, what's really interesting about this is that the model works entirely on fixed geometry. It uses 0 free parameters, absolutely no adjustable dials whatsoever. Everything is securely locked into just 3 variables. First, baryonic mass, which is just the observable normal matter we can actually see. Second, the Hubble flow, representing the cosmic expansion rate. And third, the toroidal geometry itself, where the topology is mathematically fixed. It is a closed mathematical circuit that leaves absolutely no room for arbitrary tweaking to fit the data. Basically, if the model is wrong, it will fail spectacularly because you can't just invent a new variable to save it. But as we're about to see, it doesn't fail. Moving on to Part 3, an optical illusion, resolving the Hubble tension. Okay, imagine you are actually standing inside this giant donut. Because a torus has a distinct center axis, called the poloidal axis, and a distinct outer edge, the toroidal axis, the universe actually looks physically different depending on which way you look. It's entirely a matter of perspective. The ITSM proves mathematically that if you measure the cosmic expansion looking down the center, the geometry naturally yields exactly 67.4. But if you measure along the outside edge, it yields 73.0. Depending on our literal vantage point on Earth relative to the overall structure of the cosmos, the light reaching us from different directions is stretched differently by the sheer geometry of space. So the crucial point is, the Hubble tension isn't a crisis at all. It is a mandatory 8.3% geometric variance caused by the anisotropic nature of a torus. Because we are looking at the universe from a specific, fixed vantage point, the expansion rate is literally supposed to look different across these two axes. It's an optical illusion built right into the very fabric of space. The two numbers don't conflict at all. They're really just measuring two different curves of the exact same donut. And this brilliantly illustrates just how staggering the results are when we map it out. Looking at the data from the ITSM analysis, it charts the expansion rate across 175 actual spark galaxies. The model's global distribution perfectly bridges the gap between the early universe CMB measurements and the local distance ladder. This isn't just some mathematical guess. This is published, falsifiable data aligning perfectly with actual observation, achieved entirely without dark energy or dark matter. It smoothly connects the 67.4 and the 73.0 across the vast distances of space. It's incredible. Section 4. A new perspective. Multiscale falsifiability. For any new theory to actually rewrite physics, it has to work everywhere, right? And the ITSM delivers beautifully on that front. The exact same geometry that solves the Hubble tension also analytically recovers galactic rotation curves, completely removing the need for those imaginary dark matter halos. But wait, it gets better. It accurately predicts a specific acoustic resonance peak in the gravitational wave background at exactly 2.11 nanohertz, which is something the nanograv collaboration recently observed in real life. It even derives an evolving dark energy signature natively from what the model calls centropic volume decay. It's just amazing to read through. One single geometry seamlessly locking the entire universe together without relying on a single invisible placeholder. So, taking a step back, as we look at the sheer, sweeping scale of this model, we arrive at a truly profound realization. The universe isn't broken. We were just looking at it from the wrong angle. Which ultimately leaves us with a massive question to ponder. If the true shape of the cosmos has been hiding in plain sight all along, mimicking invisible dark matter and dark energy simply through the geometry of a 3-torus manifold, what other cosmic mysteries are just waiting for a simple change in perspective? Thank you so much for joining me on this explainer. I highly recommend checking out the source material to explore this toroidal universe even deeper. Until next time, keep questioning and keep looking up.